I literally cannot believe that a bloody microphone, like a wired microphone, is literally better than like the specialty microphone that I bought for like 24 bucks or something. Like, what the heck? Like, come on. Like, a microphone isn't microphoning. What the hell? Hi. I'm a little sick, but that's besides the point. So, I haven't touched this channel in quite a while actually. And let's just say I've been quite busy over the space between my last video and this current one. Up to date, basically what happened is, I'm just preparing for university and stuff, so that's like a big hectic and all. But I am free now, and with free time comes boredom. So I wanted to try something new, something innovative, something fun. Okay, maybe not innovative, but it is an interesting idea. It's basically a new YouTube series I want to try. So, I present to you, ladies and gentlemen, answering questions absolutely nobody asked for, like an actual journal article. AQANAFLAAJA for short. In this series, I try to answer questions like, how many holes does a straw have, stuff like that. What I do is, I try to include sources that backs up my points, and in a way, it would feel like something that is more concrete. I will include calculations, so on and so forth. That way you can actually trust what I'm saying. So, yeah, if I'm using sources and I get something wrong, then that's definitely not good. Anyway, so yeah, some of you may be wondering, what does journal article mean here in that title of the series? Well, here's what's happening. Before I make this video, I have a Word document with a bunch of questions. Then as I answer the question, the Word document gets longer, and by the end of it, hopefully, I will have a complete document that looks like an actual research journal, because the document will have explanations, the questions I use, diagrams that I've included, but most importantly, the sources that I've used to back up my claims. So it's definitely an interesting idea, right? So yeah, introduction aside, I welcome you to the first episode of answering questions absolutely nobody asked for, like an actual journal article. Today's first question: which everyday object is unnecessarily over-engineered? Now, this question does seem a bit complicated, or rather like subject to opinions and stuff, but I do have a personal favorite, and that is the ballpoint pen. Now, before I do say anything more, I will point out that while the question asks which is over-engineered, what I actually mean is, what is something more complicated than people give credit for? Because let's be real, if something was over-engineered, it costed more than you could have spent, which is a waste of money, and that's just not a thing in this economy. The pen. It seems quite simple at first. I mean, it's an ink cartridge, and then a tip which has a ball in it, and then the ball rolls around and bing bang boom, you're right. But no, it's actually quite more complicated than that. And to show you, this is a diagram of the tip of your standard ballpoint pen. So it's got an ink column, a ball housing, the ball itself, and ink flow channels. Now this is already quite complicated, especially when you consider the scale at which this is happening. In essence, the ball is rolling around, and as it rolls around, the ink sticks to the ball, which then rolls with the ball until it reaches the page, and that's how you write. It's easy, right? Wrong, no. This is more intense in practice. Firstly, the housing that holds the ball needs to allow ink to flow around it without overflowing. Not only that, you also have to stop it from seizing. So, when you're pushing down on the ball, it needs to be consistent with how much ink it releases. That's not easy to do. The geometry in the tip of a ballpoint pen is quite important because you can't mess it up. If it's too wide, the ball might fall off when you press too hard and the ink will just spill everywhere. But if it's too tiny, the ball will just start rolling, you just won't be able to write. And you have to consider the demographic of people writing. Some people write harder, some people write softer. The ball needs to handle all of those conditions. Not only that, when you push down on a pen to write, the force that we use to write results in ridiculously high pressure between the ball and the surface you're writing on. And to prove that, I'm going to do a simple calculation. Let's assume a simple 0.7mm pen. The ball in said pen would be also 0.7mm, and so the radius would be 0.35mm. Realistically, the surface contact area between the ball and the surface you're writing on is 0.0025% of the ball's total surface area. I'm making a huge assumption here. You can see on the screen if you want to know more. But essentially, That means for a ball of 0.00035 meters of radius, its contact area with a surface is about 0.38 into 10 power minus 11 meters squared. This is like really tiny. For scale, a human hair is 3.8 into 10 power minus 9 meters squared. How much smaller is our surface area than a human hair? To those who answer the question, yes, that's right, it's 100 times smaller. If you took your hair, plucked it out of your head, split it, and compared the cross-sectional area between a hair and the surface contact between the pen and the page, that pen and page surface contact is 100 times smaller than the width of the average human hair. And if you take a blood cell, its surface area is 1.3 into 10 power minus 10 meters squared. This contact area is 10 times smaller than that of a blood cell, which is insane. Now, that's not even the most insane part. When we calculate pressure, so looking it up, I found that we can assume it's about 1 Newton of force that we use when we write with a pen. Obviously, it depends on handwriting to handwriting, person to person. But this 1 Newton alone would result in a pressure of 2.6 into 10 power 10 pascals. For context, because it's such a huge number, you can't really think of it, right? It's 26 followed by 9 zeros, pascals. For context, if you go to the bottom of a very deep ocean trench, the pressure is 260 times less than that of a ballpoint pen. And that's not even the most insane part, because this same 2.6 into 10 power 10 pascals is only a 14th of the pressure inside the Earth's bloody inner core, which is a lot. So yeah, you get it, right? Our ballpoint pen needs to be able to handle those insane kinds of pressures. You can't just make it out of steel or copper or whatever cheap metal you have. You need something that can withstand those pressures, not crack, and last for a very long time as you continue to write. So what other material can we use other than the beautiful tungsten carbide? Tungsten carbide is not cheap and is not some easy material to get. This is like almost as hard as diamond. And while it is a stretch to say it's some of the hardest, like strongest materials we have, it is still up there. This is not your average material. You do not see these just anywhere. For context, tungsten carbide is used to make end mills in CNC machines and really strong surgical tools. But my favorite use of tungsten carbide is in armor-piercing rounds. Tank go boom. That's exactly what happens. And the fact that pens cost like maybe $1, maximum $2, depending on what kind of pen you get, it's kind of a bargain. So the next time you use a pen, remember that that pen had to sustain insane pressures, several times more than the bottom of the ocean and more than the 10th of the Earth's inner core or whatever, but that's still a lot of pressure. And it has to survive wear and tear, and the fact that you're pushing on it means that the housing has to survive wear and tear, and that it shouldn't release too much ink or too little ink and all that stuff. A lot goes into the engineering of a pen, and to be frank with you, I haven't done it justice. I could have gone much more deeper, but to be fair, I did kind of rush this video, so whatever. So yeah, that concludes the first episode of answering questions absolutely nobody asked for, like an actual journal article. If you do like this, please do show your support, like the video, or just watch it. Or if you do have any questions that I think you should know, that you think I should include in the video, do say so in the comment section or whatever. Okay, thank you, bye.